Welcome back to another class. So here we're going to be looking at past questions on friction and circular motion that we just looked at. So as usual, I would say you guys can pause the video, or just download the questions, okay, from the description. Then just head on to solve on your own, and then come back to watch the video to see how the questions are actually supposed to be solved and to get corrections if needed. Okay, so the questions are, as you can see on the screen, okay, there are 6 of them, and we're going to be looking at them. Okay, so the first question is, an object of mass m moves with a uniform speed of v round a circular path of radius r. If its angular speed is omega, the magnitude of the centripetal force acting on it is, we have A to be m omega squared r, we have mv squared over r, we have m omega r, we have mv squared over r squared. Of course, from the class, you should just remember that centripetal force is mv squared over r. So for question 2, we have a body of mass m kg rests on a plane, inclined at an angle theta to the horizontal. The component of the weight of the body parallel to the plane is... Okay, now this can be quite confusing, but very straightforward if you understand the concepts relating to it. So let's say we have a body. Let me just get to draw a body here. So let's say we have an inclined surface and we have a body, okay, resting on it. Okay, now this body has its mass, okay, its weight acting downwards. So we have this as mg, okay, acting downwards. Okay, remember, note that it acts vertically downwards, straight down. Okay, it's not inclined, its weight. Now also note that, let me elongate this. Okay, so if you draw a horizontal here, a horizontal line, this is given to us as theta, right? Okay, so this is theta because it's the plane inclined at an angle theta to the horizontal. Now they're asking for the component of the weight of the body parallel to the plane. When you say parallel to the plane, you mean the component of weight in this direction. That's parallel. This is parallel to the plane. Okay, so what do? First of all, we know that if we draw another line like this, that is perpendicular to the incline, now it's going to be theta degrees away from mg. When I mean theta degrees away, I'm talking about the actual, when I mean theta degrees away, I'm talking about this actual theta here. So considering this incline now, if you're using this incline as a reference, this is the horizontal and this is the vertical. So mg is theta away from the vertical of this body. Of course, remember, we're using the incline as a reference. Now, from the previous class, it was stated, when we studied scalars and vectors, it was stated that if we're trying to resolve a vector into its vertical component, okay, we use mg sine theta, all right, where theta has to be the angle that vector makes with the x-axis, the horizontal. Now, using this incline as a reference, this is our vertical, these are horizontal, this is mg. We're looking for the horizontal component of mg. Okay, we are looking to resolve it into its horizontal component, but we have theta, which is the angle it makes with the y-axis. So there are two things. It's either we're going to find theta it makes with the x-axis and then have mg, all right, cos, instead of theta now it's going to be 90 degrees minus theta. That's because we're looking for this angle it makes with the x-axis. Okay, but then our question doesn't give room for this. Our answers and options has nothing like this in store. So we're supposed to use just theta to get an answer. And it was also mentioned along this course that if we need to resolve the vector with the angle it makes with the y-axis, then we're going to have mg, instead of cos now, we're going to have mg sine, okay, sine theta. this is for the horizontal. So we're either using mg cos 90 degrees minus theta, where this whole thing in the bracket is the angle made with the horizontal, or mg sin theta, where theta is the angle made with the vertical. Alright, our answer is mg sin theta, which is A. So question 3. An object of mass 2 kg moves with a velocity of 10 meters per second round a circle of radius 4 meters. Calculate the centripetal force on the object. So this question is from JAM 2011. Alright, so if we look at the parameters we're given, we'll see we have mass as 2 kg, we have velocity as 10 meters per second, we have radius as 4 meters, and we're asked to find centripetal force. So, of course, we know the formula for centripetal force is mv squared over r. So we have our mass, we have our velocity, and we have our radius. So all we need to do is just put in our parameters and solve for an answer. So we have mass 2 kg times 10 meters per second all squared divided by 4 meters. Okay, so we have 2 kg times 10 should be 200 kilogram meters per second squared. Of course, 1 meter here, since this is meter squared, 1 meter goes because of the one down here, so they divide themselves. So we have 200 kg meter per second squared, which gives us 50 newtons. Okay, and that's our answer for question number 3. So we'll move on to question 4. A load is pulled at a uniform speed along a horizontal floor by a rope at 45 degrees to the floor. If the force in the rope is 1500 newtons, what is the frictional force on the load? Okay, so this is from JAM 2012. So we have our options here, and then let's go straight to the question because this doesn't require much. Let's recall from the class we had previously. So we're told that we had 2 types of friction. We had the static friction and the dynamic friction. And we said that the dynamic friction is that friction that has to be overcome for an object to move at uniform speed. Okay, so you can see here that this question is saying that the load is pulled at uniform speed, okay, along the horizontal floor. So it means that the dynamic friction is what has just been overcome. Okay, so this force being applied is the force that was used to overcome the force of dynamic friction. Alright, so if we find out what the force is, the effective force in the horizontal direction, of course, is pushed along the horizontal floor. So if we find out the effective force in the horizontal direction, then we would have found the frictional force on the load. Okay, so just to create a form of perspective, okay, it's more like we have this box on the floor. Let's assume this is our horizontal ground. All right, sorry, I slanted it, but let's assume that's the horizontal ground. Okay, and it's at this rope is being pulled at 45 degrees to the ground. So it's still, let's say that's still a projection of the horizontal ground. So the angle here is 45 degrees, right? Okay, so we're asked to find the frictional force. Okay, now remember that the frictional force acting on this body is not at an angle, is acting horizontally against motion. So if we need to find this frictional force, then we need to find the effective effect of this force, this pull force in the horizontal. So we're going to find the horizontal component of this force. So because the force is a force of 1500 newtons, okay, we find the horizontal component. Of course, 45 degrees is the angle that force makes with the horizontal. So we simply just do F cos 45 degrees to get our answer, which is 1005 cos 45, which gives us 1060.1 newtons. Okay, so this is the force that was required to overcome the force of dynamic friction for this object to start moving at uniform speed. Okay, so number 5, we have the diagram above illustrates the body of mass 5 kg being pulled by horizontal force F. If the body accelerates at 2 meters per second and experiences a frictional force of 5 newtons, calculate the A, net force on it, B, magnitude of F, C, coefficient of kinetic friction. Okay, so if we have this, it's similar to what we just did now, what we just solved. Okay, this diagram, alright, is already letting us know that our F is in this direction and our frictional force in this direction. Okay, so and the F is a horizontal force, which was already stated here. Alright, if the force applied makes this object moves at 20 meters per second and the frictional force was 5 newtons, we are asked to calculate the net force on it. So the net force here now, of course, the net force on this object is the force that will create an acceleration of 2 meters per second, right? Alright, so if we just bring in the formula for force, which is mass times acceleration, we know the mass, we know the acceleration, of course, put it into the equation, we'll get the net force that is supposed to generate that acceleration. So that's what we've done here. So we have mass as 5 kg and acceleration as 2 meters per second squared. If we multiply that out, we have 10 newtons. Alright, so we can see that the force put on this system, a system that has both frictional force and a force applied on it, the force that is needed to create an acceleration of 2 meters per second is 10 newtons. Now, the second question is, what is the magnitude of F? So now, what is the value of F? Within that net force, what is the effective force of F that needs to be put into the system? So if we exempt force first from this system, it's a system that has a frictional force of Ft and has a mass of 5 kg. Okay, so what force can be put on this system to generate the acceleration of 2 meters per second? Okay, so now to get that, we already know our net force is 10 newtons, but that 10 newtons is made up of the force applied here and the frictional force. So it's simple. If we want to find the net force, we're going to be subtracting frictional force from that net force to get F. So that's what we did here. Net force is equal to F minus Ft. Okay, so that will mean 10 newtons equal to F minus 5 newtons. So if we take the frictional force to this side, it becomes 10 newtons plus 5 newtons. Please take note of the signs. Alright, take note of the signs. So 10 newtons plus 5 newtons will give us 15 newtons. Now, net force is F minus Ft, because two ways we can look at it. If you look at this diagram, alright, based on the x-axis and how anything to the right side of the x-axis is positive and to the left side is negative, we'll see that this is F minus Ft. Okay, so that's one way to look at it. Another way to look at it is, for us to have a net force of 10 newtons, the force that is applied that causes that motion must be greater than the frictional force. And if that is the case, to get the net force, we have to subtract the frictional force from the force applied. Okay, so those are two ways to look at it to know how to place your signs. Okay, so we have everything to be equal to 15 newtons. So the force applied here as F is going to be 15 newtons for it to generate an acceleration of 2 meters per second. Okay, so the third question asks us to generate the coefficient of kinetic friction. Of course, we know that mu is equal to F over R from the class. Alright, and mu stands for the coefficient of friction. Alright, in this case, which in this case is the coefficient of kinetic friction. So what's our F? Our F is 15 newtons, which we've just gotten, and our R, which is a normal reaction. Okay, we remember that our normal reaction points upwards here, and it's the opposite of the force of the weight of this object, which is mass times gravity. So our normal reaction is equal to the weight of the object. So that's why we have 5 kg times 10 meters per second squared. Alright, so 15 divided that will give us 0.3 as our coefficient of kinetic friction. Remember, there is no unit for this, so it's dimensionless. Question number 6, we have two forces, 100 newtons and 60 newtons, acting on an object of mass 10 kg. Okay, neglecting friction, calculate the acceleration of the object. Alright, so basically we have mass and we have force, and we asked to calculate acceleration. So it's supposed to be a simple implementation of force equal to mass times acceleration. But then we see that one of the forces is inclined at an angle. So we have to resolve it into its horizontal component. Okay, because this object is not going to move in the air. It's not going to move in this direction. It's actually moving in the direction of the horizontal on the ground. Okay, it's moving along the ground, so it's moving horizontally. So we need to find out the horizontal effect of force 1 and force 2. So in that case, we find the horizontal component of this force, in fact, of both forces. These are our parameters. F1 is 100 newtons, F2 60 newtons, mass is 10 kg, and we have to find the acceleration generated from the setup. So we know acceleration is force over mass, which is definitely from force equal to mass times acceleration. So we have to find our force. Okay, we have to find the horizontal component of all forces we apply to this body. So F is equal to 60 newtons. Of course, 60 newtons cos 0 gives us 60 newtons. So we have 60 newtons plus 100 newtons cos 45 degrees. Alright, so if we simplify this, we get 130.7 newtons. Okay, so now we divide this by our mass to get our acceleration. Since our mass is 10 kg, we have 13.1 meters per second. Alright, so that is our answer.